So we're gonna continue with trig. Now for the starter question, right, as always, I am going to ask you to pause the video, plot this point on a Cartesian plane, okay? So do that. Obviously, I'm going to proceed anyway, so I'm expecting you to pause. So let's just quickly do this. So, Cartesian plane, you have x, and you have y. Now, the key thing to understand is that the first coordinate, right, always represents your x value. And the second one is your y value, okay? Because, x comes before y in the English alphabet. And the mathematicians, I guess, decided to stay consistent with that. Okay, so my x value is 1 and the y value is square root of 3. Okay, now you can scale this however you want. Okay, I don't know why some students are always under the impression that you can only increase your scaling by 1. No, that's not the case. Okay, I have chosen square root of 3 because it's going to be a lot more convenient. So when you do that, then your point will go somewhere over here, right? Because your x value, x coordinate is 1 and then y coordinate is 3. Now, so hopefully this is what most of you got. Now, what I'm going to ask you to do is whenever you plot a point, I'm always going to ask you to connect that point to the origin. Now, this is not what the question was asking you to do, but it's a wise thing to do. And also connect that point to the x-axis, okay? So this is your x-axis, right? So connect it to the x-axis, because when you do that, you're actually going to have a right angle triangle. And if you kind of like, analyze this a little bit more, you will kind of conclude that this, side or the height of the triangle, if you want, right, measures the square root of 3. And this side of the triangle, right, your base, if you want, measures 1, right, based on the coordinate that you have, okay? And we're going to be making use of this fact, okay? So please, whenever you draw a point, get in the habit of connecting that point, right, this point over here, to the origin, and also connecting the point to the x-axis, okay? And then you'll always have a nice um, right angle triangle. And maybe another thing that I'm going to point out is that remember the reference angle, right? It's the acute angle between the terminal arm and your x-axis. Okay, so we're talking about this is your terminal arm, right? And your x-axis, which is this. So this is your reference angle, theta r. Okay, so from yesterday, right? If hopefully I'm hoping that you're up to date with the videos, but um, this is your reference angle. Okay, so again, if you're not watching the videos, you will be lost in my other classes because everything is cumulative. Okay, so you need to know what reference angle is to follow this class. Okay, if you don't know what a reference angle is, then go back and watch yesterday's video before you start watching this one. Okay, so now okay, I made this table beforehand in the hopes of saving a lot of time. So these are the exact trig ratios. Okay, so it turns out when you increase your angle by 30 degrees, so you start at 0, right, and then you increase it by 30, and then you increase it by 30 again to go to 60, and then 90, and then 120, and so on and so forth, you're gonna get exact trig values. Um, um, so multiples of 30, but also multiple of 45. Okay, 45 is kind of like the odd person out over here. So multiple of 30 and multiple of 45 will give you nice ratios. Okay, so if you use your calculator, right, and you calculate cos of 0 degrees. Okay, so the 0. So if you do cos of 0, your calculator will give you 1. Okay, now if you do cos of 30, your calculator will give you an ugly number, right? So cos of 30, I think, is 0.866. And it is 0.866. Okay, so what I'm going to ask you to do is, this will help you a lot. Just memorize this fact that square root of 3 over 2 is approximately equals to 0.866, okay? Because when you will use your calculator, which you have the right to do, um, and if the question is asking you to find exact values, whenever you get 0.866, you should know that 0.866 is actually square root of 3 over 2, okay? So this is um, a fact that I want you to memorize. Now, it's not exactly 0.66, right? It's an ugly number. So this one I am going to ask you to memorize. Okay, whenever you see 0.866, that not just it's like an irrational number, right? So it's not zero. That's why I'm putting this approximate sign over here, right? Whenever you get a value that's approximately 0.866, the exact value will always be square root of 3 over 2. And in a similar fashion, I want you to, so if you take your calculator, right, and you compute cos of 45, you're going to get 0.707, I think. So let's do that. Cos of 45, you get, make sure you're in degree mode, okay? So for those of you who are not getting these values, make sure your calculator is in degree mode. So as it turns out, square root of 2 over 2 is approximately equals to 0.707, okay? And I want you to memorize this fact as well, okay? So when they are asking you to find exact values, the best way to do a question like that is to just use your calculator. If you get 0.707 as your answer, then you should know that, oh, that's just square root of 2 over 2, okay? And the other numbers are nice, okay? What do I mean by that? So there's five possibilities, right? You're either gonna get 1, or you're gonna get half, or you're gonna get 0. So these three are nice numbers, okay? You don't have to worry about them. You use your calculator, you're gonna get an exact value. But once you start getting 0.66, 0.707, then it has to be one of this one, okay? And you need to know which one it is, okay? So that's a trick that I used to use when I was in high school. Um, but with that being said, now again, this stuff you can just use your calculator and figure it out. But the question remains, right? Some of you might be asking, well, why is cos of 0 equals to 1 and sine of 0? So why is cos of 0? Let me use some different colors. Okay, so cos. Why is cos of 0 equals to 1? And why is sine of 0? So should I go with let's go with black, okay? Because I really use black. So why is sine of 0 equals to 0? Why is that, okay? And the reason is because this is important. I want you to think as sine theta is actually your y coordinate, okay? So sine theta doesn't really look nice. So sine theta is actually your y coordinate, and cos theta is your x coordinate. Okay, that's how you get these values. Now, this will all make sense hopefully in a moment. Okay, but I want you to remember that cos theta is your x coordinate, sine theta is your y coordinate. Okay, so if your angle is 0, remember 0 degrees, right? So remember from yesterday's class, you always start from the first quadrant, right? So your angle over here is actually 0 degrees, and then you have to move in counterclockwise direction, right? So if this is 0, then that means that your angle over here is 90 degrees, okay? So if you are at 0 degrees, and I'm asking you to make a terminal arm that, connects, I guess, the origin, right? So the center of the circle to the circumference, right? At 0 degrees, this is what you're going to get. This over here, right? So this will be your point. When theta is equals to 0, this will be your point. Now, let's think about the coordinate. Okay, at this point, what is my x coordinate? My x coordinate is 1. My y coordinate is 0, right? Which is what I have over here, guys. Okay, so my x coordinate cos theta is 1, and sine theta is 0, okay? And there's also a nice relationship. So if you look at these numbers, you have 1, and then the square root of 3 over 2, square root of 2 over 2, half, and then 0. Sine also has the same values, but it's starting from um, what you have in the bottom over here and going upwards, right? So it's the direction is different. So you start from 0, and then the next one is a half, which is here, and then square root of 2 over 2, right? Both of them are the same value. It's because 45 is actually like midway, right? So it's kind of like midway between 0 and 90, which is over here. So, I'm hoping this kind of makes sense. And, maybe your teacher in 30-1 will expand more on this fact. But let's just proceed a little bit. Okay, so I've already done this one for you, right? So the 1, 0. Now let's target 90. Okay, so if this is 0 degrees over here, then 90 degrees has to be there, right? Because see this um, has to be 90, right? Because it will make a right angle. Oops, it's not working really well. So, okay, now I think it looks better. So think about this point over here. Okay, what is your x coordinate for this point? Turns out your x coordinate is 0. And because, I've drawn this circle, right, maybe I should have mentioned that the radius of this circle is equals to 1, okay? The radius of the circle is equals to 1. So which is why this point was 1, 0. So this one, because it's the same radius, your x coordinate has to be 0, your y coordinate has to be 1, okay? Which is where this is coming from, okay? So I'm only going to point that out, but maybe let's just do one more because I'm really getting excited over here. So let's just do one more, okay? So um, let's just focus on the next one, 30 degrees. So if I increase my angle by 30 degrees, that means my terminal arm will be somewhere over here, right? So this is 30 degrees, okay? And this will also have an x coordinate and a y coordinate, right? So it turns out my x coordinate, as you can see, will be very close to 1, right? This is 1. This over here is 1. This has to be very close to 1. And if you use your calculator, right, it's actually the value of this is cos, right? Because cos is your x coordinate. So if you take cos of 30, you're gonna get 0.866, right? Which is very close to 1. But the exact value of that is square root of 3 over 2. And if you take the y coordinate of this, will just be sine of 30. But if you do sine of 30 in your calculator, you're gonna get a value of half, okay? So as you can see, as you increase the angle, right, as you increase the angle from 30 to 45, your y coordinate will increase, but your x coordinate will decrease. So your x coordinate will decrease until it reaches 0, right? Which is what you see over here. And your y coordinate will increase until it reaches 1, which is what you see over there, right? But the thing is, right? The thing is, you can continue. You can even go over here, okay? And you're going to see those same values. The only difference is that now they're going to be negative, okay? We're not going to do any of that because I want to keep this simple. Um, Hopefully, I did not confuse you too much. I was just trying to show you where these values are coming from, okay? The key thing to remember over here is that cos theta is your x value and sine theta is your y value, okay? And if you use your calculator, you can actually generate these numbers. The only thing that you have to remember though, because they will ask you for exact values, is that square root of 3 over 2 is 0.66. So whenever you see 0.66, just know that it's square root of 3 over 2. And if you see 0.707, then it's square root of 2 over 2. Okay, so that's something that I'm going to ask you to memorize for now. Okay. Um, okay, so let's continue. Here, we're gonna just review SOHCAHTOA. So this is from grade 10, right? So which is kind of like what I did. So basically, um, right? So hopefully, you know what SOHCAHTOA stands for. So I'm gonna start with let's start with SO, right? SO gives you the sine ratio. So S over here stands for sine. O is opposite and H is hypotenuse, right? So this just tells you that if this is your angle, right, theta, then sine theta, right, S over here stands for sine, and then O stands for opposite. The side that's opposite to your angle, which is Y, over your hypotenuse, which is, in this case, it's R, right? It's the radius, okay? And the reason why they're using a radius, because, just like in the previous question, if you kind of like rotate your radius, you're eventually going to get a circle, right? So that's why they're using r. Right? And if you solve for y, then you have to get rid of this r, right? So if you multiply by r on both sides times r, and the r's will cancel, right? So y will equals to r sine theta, right? Which is what I asked you to do. I asked you to think of y as sine theta, okay? And in my case, that kind of made sense because your radius, remember, was equals to 1, okay? Here they're kind of like generalizing it, okay? So what if your radius is not equals to 1? Then y will equals to r times sine theta, okay? And right now let's do ka. So maybe let me use a different color, right? Ka over here, the C stands for cos, so cos theta is equals to, so the A over here is your adjacent side. So the side that's adjacent to theta is this side, right? Which is x over hypotenuse. Your hypotenuse is again r. So if you solve for x, then x will just equals to r cos theta, okay? Which is kind of like what I showed you, except that in my case, I picked a unit circle, and you will talk a lot about unit circle in 30-1. So if r is equals to 1, then x is just cos theta, right? And tan finally, so let's use a different color for tan. Tan theta is just, using this, right? TOA. So T stands for tan, O stands for opposite. So the side opposite to theta is, whoops, the side opposite to theta is y. And the side, right, so the O stands for opposite, A stands for adjacent, adjacent is x, okay? So this is the general case, okay? So the general case. Now, let's do some questions and hopefully this will make more sense. Okay, so again, see, they're telling you that the point P, minus 815 lies on the terminal arm of an angle theta in standard position. Determine the exact trig ratios of sine, cos, and tan. Okay, so just like the starter question, what you have to do is just plot the point. Okay, so let's make a Cartesian plane. This is x, that is y. So remember, the first coordinate is x, the second coordinate will be your y value, right? So x is -8, y is 15, and again, I can scale this however I want, right? So this is your point. So what I'm going to ask you to do is to connect this point to the origin, right? That's the first step, and also to the x-axis, okay? And find the reference angle. So now the reference angle, right, guys, has to be between the terminal arm, right, which is this, and the x-axis. So this is your theta, okay? Now, we're gonna find the ratios, okay? So, um, again, if you want, let's just use a different color. So the height of this triangle, right, using the coordinates is my y value, which is 15, and the side length or the base length of this triangle is 8, right? So this -8 is your coordinate, but length cannot be negative. So I like to view length as positive, a positive value only. Your textbook does it a little differently, but that might get confusing um, next class. So I'm gonna avoid negatives because length is by definition has to be positive. Okay, your coordinate can be negative, yeah, that's fine, but not your length. So let's find the ratios. Okay, using SOHCAHTOA. So remember SOHCAHTOA, right? So let's write it out. Let's just do it over here. SOHCAHTOA, right? So when you're finding sine and cos value, you need your hypotenuse, which is not given to us, okay? So when the hypotenuse is not given, what you have to realize is that when you connect your triangle this way, this is a right angle, right? So the side opposite to your right angle will always be the hypotenuse, which, because we're doing trig, instead of calling it h, we just call it r because it's essentially your radius, okay? And you guys are very familiar with this formula, right? A squared, the Pythagorean theorem, a squared plus b squared is equals to c squared. Um, in the Cartesian plane, right, it translates to x squared plus y squared is equals to r squared. Okay, so you could use whichever one you want. Okay, I tend to use x squared plus y squared is equals to r squared, because it kind of makes sense to me that this here is my x coordinate, right, and this is my y coordinate. Um, so I am looking at this triangle, but if it's confusing you, then don't do that. So I don't know how you guys are gonna approach this question, but this is one way of doing it. So, you know, I guess just to not confuse you, um, let's just stick with a squared plus b squared is equals to c squared. So, I guess the key thing to realize is that your hypotenuse is the C value, right? And that's the most crucial piece of information because A and B are irrelevant, okay? So I could choose this to be A, and this to be my B value or vice versa. It doesn't really matter, okay? So using that, 15 squared plus 8 squared is equals to C squared, right? Now, if you expand that, you get 15 squared plus 8 squared, which is 289 is equals to c squared. But I'm not interested in the c squared value, right? I'm interested in the c value. That means I need to get rid of this squared. So I have to take the inverse. So the inverse of squared is square root, square root. So c will equal to, I think 17. So square root of 289, 17, okay? And now I have my radius, okay? Or the hypotenuse or whatever you want to call it, okay? So this is 17. And now we can find our famous ratios, okay? So sine, right? S over here stands for sine. Sine of um, my angle, theta. Okay, this is, I'm going to call this theta r, okay? But we are not finding theta r. What we're interested in is the value of this angle over here, which is theta, okay? So maybe let me be consistent with my colors. So I am interested in sine theta, but not theta r theta, okay? Um, but you can use theta r to find theta, okay? So how am I gonna do this? I hope Josh is listening. I'm gonna cheat, okay? So how will I cheat? I am just gonna look at this theta r angle, okay? I'm just gonna look at this angle and then insert my plus and minus signs manually, okay? So what do I mean by that? So if I'm focusing on theta r, O is my opposite side, right? So if this is my angle, my opposite sine is 15, right? And my hypotenuse is 17, right? I just calculated that. So this is my hypotenuse. So sine theta is 15 over 17. Now, guys, remember I said that sine is your y value, right? So if you look at this point over here, is your y coordinate positive? Yes, it is. Okay, so your ratio also has to be positive. So you're just going to leave it like that. Okay, now for for cos, right? Next comes cos. Cos, again, I'm going to use the theta in the green because what I'm looking for is the cos value of that angle. Okay, but I'm going to cheat, right? I'm going to use the reference angle to guide me. So the reference angle tells me that I have to look at so this is my reference angle over here, right? And the side adjacent to this angle is this one, right? Which is 8. And my hypotenuse is 17. Now here, you have to be careful, right? Because remember, um, maybe let me add that, okay? So y is your sine, right? The y coordinate is sine theta, and the x coordinate, the x coordinate is cos theta, right? But if you look at the x coordinate of this point, is the x coordinate positive or negative, right? It's on the left. If it's on the left, then my x coordinate is negative. So you're gonna have to insert this negative sign manually, okay? So that's the tricky part. So the reference angle will guide you. It will give you the right ratio, as you can see, but you will have to insert the negative sign manually based on where the point is located, right? So if the point was, let's say, located somewhere over here, then both my y and x value would have been negative, okay? So this would have been negative too, okay? So you really have to draw a picture and the picture will guide you, okay? Um, I hope this kind of makes sense. And finally, tan theta. Okay, tan is also kind of tricky. So how should I do this for you? Tan theta is equals to, right, using SOHCAHTOA, it's opposite over adjacent. So my opposite sign is, right, by looking at my reference angle, my opposite sign is 15, and my adjacent side is 8, okay? Now this one's kind of tricky because tan is neither your x nor your y value, right? But you know that tan theta, right, is also equals to x over y, or sorry, y over x, right? Tan is equals to y over x. Where is this coming from? Let's go back from here. Okay, so it's coming from here. So tan is equals to opposite, right? So if this is your angle, your opposite sign will be y, your adjacent sign will be x. Okay, so it's opposite over adjacent. So your opposite side, right, is y, and your adjacent side is x. Okay, so it's y over x. But remember, right, that your y coordinate is right, your coordinate is positive and your x coordinate is negative, right? So if you divide a positive number by a negative number, your end result will be negative. So this has to be negative, okay? So for those of you who don't really like this method, positive over negative is equal to negative, you can memorize this fact, okay? Tan theta will be positive. Maybe let me write this down somewhere, okay? So um, tan theta will be positive in quadrant 1 and 3 only, okay? And tan theta is negative in quadrants 2 and quadrant 4, okay? So what do I mean by that? If your point is in the first or the third quadrant, tan theta will have a positive value, okay? But if your point is in the second quadrant, like what we have over here, or the fourth quadrant, then tan theta will have a negative value, okay? So if you like memorizing, then just memorize, I guess, this fact. I hate memorizing, right? So one way to think about it is to just understand that tan theta is y over x. And if one of the coordinates is negative, then your end result will be negative. Okay. Now, if both your coordinates are positive, then your end result will be positive. And if both of them are negative, then your end result will also be positive, right? Which is why tan theta is positive in quadrant 1 and 3, okay? Because in quadrant 1, both your x and y value are positive, and in quadrant 3, both your x and y value are negative, okay? So, yeah. So, I don't know. I've given you two ways of remembering this. go with whatever works best for you, okay? So now your turn. I'm gonna ask you to pause the video, plot the points, and find the exact trig ratios, okay? So I'm hoping that you were able to finish this question. So x, y, right? So this is my x coordinate, this is my y coordinate. So I'm gonna plot that. So x is -5, y is -12. So I am somewhere over here, right? So all you have to do is just connect this point to the origin, and that is off. So connect it to the origin and also connect it to the x-axis, and you have your triangle. Now, we're gonna make use again of the reference angle, right? The reference angle is the angle between the terminal arm and the x-axis. So this theta r, this is what we're gonna um, make use of. But what they're asking you to find is the value of this angle, right? So theta, which starts from here, goes all the way, oops. So it starts from here and goes all the way there. So this is your theta, okay? But you see, it's tough to use that angle because you can't really draw a triangle. Okay, so we're gonna make use of the reference angle. And theta here, okay, so let's start with, so let's write SOHCAHTOA. Okay, so yeah, so I'm just gonna erase this to make some space. So that's just remember that this is the theta value that you're interested in, okay? So the side length of this triangle, right? This side, your base, if you want, is 5, because I like to think of the length of anything as positive value, and this is um 12, okay? Your coordinate is -12, yes. So your coordinate is -12, but the length, right, has to be positive. Your textbook treats it as a negative value, which works for today's class, but it will confuse you tomorrow, okay? So, which is why I'm going to be consistent with what I'm doing. So please just consider your lengths to be positive and just insert the negative sign manually, okay? So, where should I write SOHCAHTOA? So let's write it over here. SOHCAHTOA, okay? So again, I need my hypotenuse, right? So let's just quickly do this. So here I'm not going to spend too much time, right? So we have, let's just do it over here. A squared plus B squared is equals to C squared, right? So let's say A is 5. So 5 squared plus 12 squared is equals to C squared. And then, so 5 squared plus 12 squared, 169 is equals to C squared. So if you solve for C and you take the square root, right, square root, then C will just equals to 13. Okay, so it turns out my hypotenuse, right, so my hypotenuse is, maybe let me use a different color. Okay, so let's just stick with this green, so 13. Okay, so now, let's start with sine. So sine, again, I'm gonna, be consistent with my color. So let's just keep the red. Sine theta, right? I'm interested in this theta that starts from here, goes all the way to my terminal arm, right? But I'm gonna make use of my reference angle, and we'll, it's not really cheating, okay? But it's just a nice way to help you. So sine, right? SOHCAHTOA tells me that sine is opposite, so opposite to my angle is 12 over my hypotenuse, okay? But remember, sine is your y coordinate. So if you look at this point over here, is your y coordinate positive or negative? It is negative, right? So see, your y coordinate is negative. So I'm going to have to insert the negative sign manually, okay? Now let's do cos. So cos theta is equals to adjacent, right? Because that's I'm going to highlight this, right? So A adjacent and H hypotenuse. So my adjacent side to the reference angle is this, which is 5. Okay, so it's 5 over hypotenuse, which is 13. Now let's look at this point again. Okay, this point over here, because cos is my x coordinate, right? Is my x coordinate negative? Yes, it is. Okay, yes, it is. Now finally tan. So let's just let's erase this. Tan theta is equals to, right? So TOA. So here, this one in green. So opposite over adjacent. My opposite sign is 12, and my adjacent sign is 5. Okay. Now, because both sine and cos are negative, right? Both sine and cos are negative. Remember, tan theta is, right? If you want sine theta over cos theta, right? Or if you want y over x or whatever, right? So because both sine and cos are negative, the negatives will cancel out and my value will be positive, okay? So tan theta has to be positive here. Now, if you are confused, right? So one way to think about it, if both sine and cos are positive, tan will be positive, or if both are negative. If one of them is negative only, then tan will be negative, which was the case over here. As you can see, in this question, my cos was negative. One of them was negative, so tan had to be negative, okay? Another way to think about this is by using this fact, right, that I showed you over here. This one over here. So which quadrant am I in? I'm in the third quadrant over here, right? My point, this point over here is in the third quadrant. And I said that if you're in the third quadrant, then your tan value, right? If you're in the third quadrant, then your tan value will be positive, okay? So, you could use that as well. But I think, when it comes to math, like you try not to memorize everything, right? So try to make sense of it. So because both sine and cos are negative, the negatives, tan, right? Tan theta is essentially sine theta over cos theta, um, which is also equals to opposite over adjacent, which is what I have here. And since both of them are negatives, the negatives will cancel out, okay? Okay, so now they will also ask you to find the exact value, okay? So I've shown you the trick, okay? This one is not too difficult. All you have to do is just use your calculator, cos of 135 degrees. So make sure your calculator is in degree mode, find the value, okay? And let's see what that works out to be. So it's probably going to be, yeah, a negative value, and then maybe, so cos of 45 is, 135. Cos of 135 is, right, minus, so this is approximately equals to minus 0.707. And what did I tell you? When you get minus 0.707, it has to be, you have two options, right? If you don't remember, this is either equals to minus square root of 2 over 2, which it is, or minus square root of 3 over 2, which it is not, right? So those are your two options, okay? So when they're asking you to find the exact value, just use your calculator, get the decimal value. If it's not a nice number like 1, 0, and a half, then just use the trick that I've shown you, okay? And, let me just kind of, give you a little bit of detail why that is the case. The reason is because if I draw 135, right, in a Cartesian plane, so this is x, this is y, right? My angle starts from here. So this is 0 degrees, this is 90, and this is 180, right? So 135 will be somewhere over here, okay? So this is 135 degrees. Now, I said that whenever you put a point, right, connect it to the x-axis. Now you see the reason is because you see your reference angle over here, theta r, is actually equals to, is your x-axis this angle bigger than the terminal arm? Yes, it is, right? So theta r, if you calculate it, theta r is equals to 180 minus 135, which is equals to 45 degrees, right? And I've shown you that cos of 45, right? If you go to my table, cos of 45, right over here, is square root of 2 over 2, right? So that's where the square root of 2 over 2 is coming from, okay? So your reference angle will give you the right value all the time. It's just a question of inserting the manual sign, well, it's the question of inserting the negative sign manually, okay? So we know that cos um, of 45 is equals to square root of 2 over 2. So cos of 135, because it's, remember cos is your x value for this coordinate is negative. It's actually minus square root of 2 over 2. Okay, but as you can see, this is a lot of work. Okay, so finding the reference angle and then looking at the table and doing this and that, right? The best way of doing it is just to use your calculator. Once you get this decimal, just understand what that decimal um, represents, what the exact value of that decimal is. And I showed that to you a minute ago, okay? So your turn, do this question. So the best way to do this question, right? So pause the video, try it, but the best way is just to use your calculator. Sine of 240 degrees is equals to, so sine of 240 is equals to, so you're gonna get something like minus 0.866, right? And I've told you minus 0.866 is actually square root of 3 over 2, but because you have a negative sign, right, just put the negative sign over here and then you're done. Okay, so this is the best way of doing it. Now, why is it minus square root of 3 over 2, right? You can draw this out. I'm gonna do this very quickly, right? So 240 is probably somewhere over here. Actually, no, it's closer to 270, so it's something like this, right? So, and then if you, connect this to the x-axis and you find your reference angle will actually be 180, so this is 60, okay? And sine of, right, this theta r, this is your theta r. So you know that sine of 60, right, based on the table, if I'm not mistaken, is square root of 3 over 2. So sine of 240 is very similar. The only difference is that now, you're right, because sine is your y value, it's negative. So for sine of 240, you're going to have to insert that negative sign manually, okay? But, this takes a lot of time and understanding. I hope you understand the reasoning behind that. But this is a good shortcut that I used to use in high school because, I wasn't, sometimes, it's, you just don't want to think too much, right? You just want to find the right answer. And I used to be like that when I was in high school, okay? So you can use this shortcut that I've shown you, or you can understand everything, which is what I like to do now. Um, and figure it out this way, okay? So you guys decide how you want to do it. Either way, you're gonna get the right answer, okay? So, and for the homework, right, I want you to practice. So please, I know the video is long, but it's trig in grade 11 is not as easy as grade 10. Okay, so you have to practice, guys. Okay, so make sure you're doing your homework, and I will be available on Thursday to answer questions during class time. Um, but if you need help on Wednesday or something, I am open to hold a webinar on Wednesday. I just want you to send me an email so that I can allocate some time for you guys. Okay, so just give me a heads up. But on Thursday, I will be there. Okay, so yeah, just I know it's a lot of information. It's kind of tough because learning from distance is not easy. But great thing about YouTube videos is that you can always pause, rewind, and proceed at your own pace. Okay, so hopefully the video is not too long. I think it might be. I just like to explain everything. So for those of you who are kind of getting it, you can obviously like. I'm hoping that you are fast forwarding the minor details. But for those of you who are not understanding, I'm gonna request you to please take your time um, and rewind the video or watch it again if you have to. Okay. And if you have any questions, just send me an email and I can host more webinars. Then you know, so this week I'm hoping to host a webinar on Thursday. Well, I will, but I can host another one if you need my help. Okay, just send me an email. Okay, thank you so much, guys. Have a nice day.